Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on brown cows, an introduction to binomial distribution. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. In this PowerPoint, we will introduce binomial distribution and show how the formula for binomial distribution works. Mrs. Borlaug uses the formula to calculate binomial probabilities and only uses the calculator for the multiplication of the values in the formula. She does not use the binomial probability distribution command that is found on the TI-83 and 84 calculators. Since she uses the formula, so will I in this video. To illustrate how binomials work, we have been using this example. All cows in a herd are brown. The probability of getting a brown calf when one of the cows is bred to a certain bull is 0.90. If 5 cows are bred to the bull, find the probabilities of getting X number of brown calves. And we're picking up in this third video looking at this problem, and now it's time to talk and introduce that concept of being a binomial distribution. So the problem that we just finished in part 2 is a special kind of problem, and we see a lot of these binomial problems in the real world and in our probability, and they are called binomials for a reason. Let's think of this example that we have shown here. A unicycle has 1 wheel, a bicycle has 2 wheels, and a tricycle has 3 wheels. Uni means 1, bi means 2, tri means 3. So when we're talking about a binomial distribution, a binomial distribution has 2 possibilities: a success or a failure. In our example that we just finished, a success was a brown calf and a failure is not a brown calf. The success is defined in the problem and not a judgment call. Again, we need notation. Notation is vital in the study of statistics. It is the language that is used in statistics. So when you do a binomial, start with labeling what your success is. Your success may be a bad part, an incorrect answer, having a boy child, or in our case, a brown calf. It is what we're looking to happen. N is the number of trials. How many trials or experiments did we run in our example? N, lowercase n, is the number of trials, and each calf is considered a trial. So we ran 5 as our number of trials. P, lowercase p, is the probability of the success, and the probability of being a brown calf was given as 0.90. Q is the probability of failure. And remember, a failure may not necessarily be a bad thing. It's just the opposite of what we're looking for, or the complement of what we are looking for. So in our case, that's the probability of not a brown calf. And if 90% of the calves are brown, that leaves 10% of the calves not being brown, or 0.10. X is the number of successes possible. So in this case, it's the number of brown calves that we could have, which would be either 0 or 1 or 2 or 3 or 4 or 5. So to introduce a binomial distribution, we need to think about the characteristics that a binomial distribution have. First of all, they have a fixed number of trials. That is the first requirement. In our case, each calf is a trial, and there was a fixed number, 5 calves at each time. Secondly, the trials were independent. Each calf had its own probability of being brown. It didn't depend on what color the other calves were. Each trial has 2 outcomes, a success or a failure. A success of being brown, a failure of not being brown. And lastly, the fourth characteristics are that probabilities remain constant for each trial. The probability for each calf being brown was the same, 0.9. So our binomial experiment, we have our variables that we use, and our 4 variables. I said 5. I'm not sure why I said 5. Our 4 variables are N, the number of trials, P, the probability of success, Q, the probability of failure, and X, our number of successes. And then the capital P, maybe that's the 5th one there, stands for the probability. So the probability of being any one of the X's is given by our formula. And this comes from where we developed it in the first 2 videos. The number of successes or ways to get a success out of N trials. The number of ways to get X successes out of N trials. I will say that one more time because I think I said it wrong the first time. The number of ways to get X successes out of N trials. So we have N, C, X, where C is the combinations. This is the number of ways or orders there are to be successful in getting 3 calves or 4 calves or no brown calves, and that should have been brown each time. Secondly is the P raised to the X. That's the probability of getting X successes, and Q to the N minus X is the probability of getting the rest of them being our failures. And we will look at this a little bit more closely in some of the later examples. And I'm going to stop again right here and pick up in the next concept in a video in of itself. And I hope this was helpful. If you need additional help, please stop by and see me in the Math and Behavioral Social Science building in room 222.